Hello, everyone. Today we're going to study about the system of equation with the two variables. Two variables means the equation that contain x and y's together. So you will have two variables. Now the way you get the solution, which is the answer for x and y value, we are using a addition method by elimination, which means once you have same coefficient with a different sign, by doing column addition, you can just cancel it out. So what you do is you multiply the equation by a proper number, usually coefficients of each other's, or any other proper appropriate number to make a opposite coefficient, and then you add it up, so it become a zero. They cancel out. So for example, if you have a 2x with a negative 2x, by adding up by column, it end up with a zero. That's the concept that we are going to use it. So when you do the system of equation by addition method, you will have three types of possible the format, three types. The first type we call that as a consistent system. So when you have this type, your answer come out like x equals something or y equals something. So you have a definite answer for x value and y value. So that's one possible type. Another possible type is that type 2, you end up with no variables. X is all cancel out or Y is all cancel out. You end up with 0 equal 2 or 0 equal negative 3. But the problem is 0 never equal to 2. 0 is 0 and 2 is 2. So we call this one as an inconsistent system compared to consistent system from type 1. And usually this one you don't have any solution. So sometimes we say as a no solution as a final answer. Now type 3 are the one that has a many solution instead of no solution. But it come out like, again, the x and y cancel out, but x 0 equals 0, and or like 5 equals 5. Both sides of equal sign, they has the same number. Because they are always a true statement for that. So we call this one as a dependent system with many solutions. 95% of your system of equation question, 90 to 95% are like a consistent system. And there are very few times you have either inconsistent or a dependent system. So today we're going to go over all of those type of questions. Now, when you have type 1, which is a consistent system, again, there are 4 different types among the consistent system. Case 1 is the easiest. Case 1 is the one that we try to have it. So case 2 and 3, we all try to convert into case 1, and then you solve it. Now let's look at the type of case 1. Case 1 is when you have opposite sign with the same coefficient. So as you see here, you have 3y and negative 3y. In x, you have 4x and x. So they have a different coefficient with the same sign. That's what we are not looking for. We are looking for somewhere opposite sign with the same coefficient. So if you look at the y value, not an x value, one is positive 3y, the other one is negative 3y. So when you do the column addition, when you add them together top to bottom, they end up with a 0. So in that way, you can get rid of the one of the letter. So you end up with only one letter x, because y cancel each other to 0. So you only have x's. So you can solve for it. So now if you do the column addition of this, 4x plus x is 5x, because x means 1x. So 4 plus 1 is 5, so 5x. Positive 3y and negative 3y cancel out to 0. 9 plus 6 is 15. So when you do the column addition, one of the letter, in this case y, disappear, you only end up with x's. Then you can solve this equation with a one variable. So you divide both sides by 5 because you want to get rid of 5 in front of x. So when you divide each one by 5, x becomes 3. So that's the first step. You try to get a one of the value of the variable by getting rid of the letters or variables which has the same coefficient with a different sign. Now, once you get a one value of x, you substitute x as a 3 because x equals 3, usually into the first equation. But if second equation looks easier or easy to substitute, then you can do that as well. But in this example, I'm going to just substitute into the first equation. So if I do that, this x become 3. So you substitute x as 3 plus 3y equals 9. So 3 times 4 is 12. You end up with 12 plus 3y equals 9. So now again, you have equation with only one variable. Then you can solve it by moving everything with the y into the other side of the equal sign by doing opposite operation. So to move 12 to the other side of the equal sign, you do opposite operation, which is minus 12 in both sides. When you do that, 3y become negative 3. Now you can solve for y by dividing both sides by 3's. So y become negative 1. So when you have an x value and y value, you can write in a set format. So x value is always first, and you put y value. So your set answer format would be 3 comma negative 1. Okay, so this is how you solve when you have a case 1 type of systems of equation. Okay, again, systems of equation means when you have a two letters of two variable, means when you have two letters in the equation. Okay, so again, to recap how to solve this, if you have a systems of equation with one of the letters variable have opposite sign with the same coefficient, you just add by column, and you find the one of the value, in this case x. You substitute into original equation, find the value of the another letter. Okay, so that's what we just did in case 1. Now let's look at the case 2. What if you have opposite sign, but it's a different coefficient? So if you look at this questions in example 2, you have opposite sign. No sign means positive. This is negative. So you have opposite sign. That's good. But you have a different coefficient. So what do we do to get rid of, let's say you want to get rid of x's in this particular case? The way you do is you have to make the same coefficient with a different sign. So normally choose the one it has a different sign, and then you multiply each other's coefficient. So which means in a first equation, when you have a 2x minus 3y equal 1, you multiply coefficient of second equation, the other one. But because they are already in different sign, you just pick up coefficient 3, and you multiply whole equation by 3. And then second equation, you multiply by coefficient of the first equation. So second equation, you change by multiply by coefficient of the first equation. So when you do that, now anytime there is a number in front of parentheses, you distribute them, right? So 3 times 2x is a 6x. 3 times negative 3y is a negative 9y. 3 times 1 is 3. And then the second equation, you also distribute them. So 2 times negative 3 is negative 6y. 2 times positive 5y is 10y. 2 times 2 is 4. Now you do the column addition because you found that you made this original equation into coefficient with a different, same coefficient with a different sign. So 6x minus 6y becomes 0. So x disappeared this case. And then when you do the column addition of y's, negative 9y plus 10y become 1y. 30 plus 4 becomes 7. So you have 1y equals 7. So y equals 7. So this particular case, you get a value of y value first. Now what do? Second step, you substitute y as a 7 in the first equation. Okay. So if I do that, instead of y, you substitute 7, so then the first equation become 2x minus 3 times 7 equal 1, which is 2x minus 3 times 7 is 21 equal 1. So you have the equation with the one variable. So now you want to solve this equation to solve for x. So you have to move everything with the x in a same side of equal sign, move to the other side by doing opposite operation. So minus 21, to move it, you do plus 21 in both sides. Make sure you understand you have to do both sides, otherwise the equality of the equation changes. So when you do that, this cancels out, you end up with a 2x equal 1 plus 21, which is 22. Now you divide both sides by 2 to get 1x, so x becomes 22 divided by 2, which is 11. So you got x value as 11. So your final answer, it become 11 comma 7. So 11 comma 7. Okay, so that's how you do that. So again, what did we do in the second case? When you have an opposite sign with a different coefficient, we are converting this one into the case 1, which is opposite sign, but it's already in opposite sign in x's. So what you do is you have to make a same coefficient by multiplying each other's coefficient, but keeping the opposite signs. So when you do that, you end up with a very nice case 1 equations, system of equations, and then you add by column and you get a one value, and then you substitute, you get a second value. So that's the steps that you're doing in case 2 type of question. Now case 3, what if you have another type, same sign and same coefficient? So if you look at this question they gave you now, equation 1, equation 2, x's, same sign, different coefficient. Y's, same sign, same coefficient. So it's easier to get rid of y's because they already have the same coefficient. So what I'm going to do is I'm going to change the sign because you already have the same coefficient. So the way you change the sign is multiply negative 1 with the one of the equation to make this whole thing as a case 1 system of equation. So first one, you leave it as it is. The second one, you multiply by negative 1 just to change the sign of the same coefficient. But when you do that, you have to distribute negative 1 to all the terms inside of parentheses. So when you do that, you end up with a negative 1 times x is a negative 1, negative x, and negative 1 times 3y is a negative 3y, negative 1 times 6 is a negative 6. So first equation, you don't change anything. But second equation, by multiplying negative 1, now you get a new equations, which is -1 minus 3y equal -6. So now this is case 1. Okay, so because you have a case 1, all you have to do is add column. So 4x plus -x becomes 3x. Positive 3y plus -3y becomes 0. So you don't write it. And 9 plus -6 is positive 3. So you end up with 3x equal 3. And you divide both sides by 3 to solve for the y. You get a value of x as 1. That's a step 1. Step 2. So substitute this value x as 1 into original equation. So when you do that, 4 times of x, but you replace x as 1, plus 3y equal 9. So 4 plus 3y equal 9. To solve for y, you move 4 to the other side by -4, -4. So 3y equal 5. So when you have a 3y equal 5, you divide both sides by 3 to solve for y. So y become 5/3. So y equal 5/3. So x value was 1 and y value is 5/3. So that's the third case. Again, whatever the case you have, your goal is converting them or make them to case 1. So you can solve them by very easily by column addition. That's why we call this one as addition method. Now look at the last case, case 4. You have a different sign with a different coefficient. Oops, how do you make this one into case 1, which is opposite sign with the same coefficient? So you can add it up to 0. So now you have to determine either you want to get rid of x variables or get rid of the y variables. Okay? A lot of people just don't know what to do. Then they usually do the match the first one as the same coefficient. So in equation 1 and equation 2, equation 1, you have 4x plus 3y equal 2. And equation 2, you have 3x plus 5y equal -4. So what do you do to match the coefficient of x's? What do you do? Yes, you multiply each other's coefficient, but the sign has to be different. So first equation, you multiply 3 because that's coefficient of the other equation. And second equation, you multiply by -4 this time, not 4, even though coefficient is 4, because one of them had to be negative, so you just randomly choose the second one as a negative. So you change this equation 1 and equation 2 this format, and after that, you distribute them. To get the case 1 equations, new case 1 equation. So 3 times 4x become -12x, 3 times 3y become 9y, 3 times 2 is 6. -4 times 3x become -12x, -4 times 5 become -20y, -4 times -4 become +16. So that's new equation came from equation 1. And second one is new equation came from equation 2. But this become a case 1 format. So 12x plus -12y become 0x. So you don't write it, 0. So cancel out. 9y plus -20y is -11. 6 plus 16 is 22. So you end up with -11y equal 22. Now to solve for the y, you always divide each side by coefficient of the y, the letter. So -11, -11. So this cancels out to 1. And so 1y become 22 divided by negative 11, which end up with negative 2. So y become negative 2. So you got one variable. So what do you do after that? Well, you plug back to original equation as y as negative 2. So when you do that, 4x plus 3 times negative 2 equal 2. So that end up with 3 times negative 2 is negative 6. So 4x minus 6 become 2. So you solve this equation with a one variable. So what has happened was system of equation with a two variable, x and y, now become x alone, equation with x alone in this case, so we can solve it. So to solve 4x minus 6 equal 2, you move negative 6 to the other side by adding 6 in both sides. So you end up with a 4x equal 4, 8. And when you have a 4x equal 8, how do you solve for x? Divide both sides by 4, so x become 2. And then now you have x value, so you put 2, y value is negative 2. Okay, so those are the example when you have consistent type of question. How about type 2, no solution, inconsistent system? They look like a case 1, or type 1, sorry. And then, but when you solve this, right, for whatever the format they have, when you solve this, so now this one, I'm going to try to get rid of x. So I'm going to multiply each equation by each other's coefficient. So this you multiply by 4. So coefficient would be 4, multiplying coefficient. Now this one you multiply by negative 2 because you have to make one of them as a negative, so you have to have an opposite sign, so negative 2. After that, if you distribute them, 4 times 2x is 8x, 4 times 3y is negative 12y, 4 times 6 is 24. So now you have new system of equation with a two variable. Now I'm going to multiply negative 2 with a 4x, negative 8, negative 2 with a 6y, negative 12y, negative 2 with a 8. So that end up with negative 16. Here is a mistake, negative 16. So now when you do the column addition, 8x with a negative 8x cancel out. So I thought I will have the y values, but negative 12y plus negative 12y cancel out again. So both x and y cancel out. So you end up with a 0. 0 equals 24 minus 16 will be 8. So here is another boo-boo. 0 equal 8. 0 never equal to 8. So it's a not true system. And there is no way you can have solution to make 0 equal 8. So no solution. So we call this one as an inconsistent system. Okay. Now, compared to that, how about dependent system, type 3? Again, you have a system of equation. So you try to solve this. So now again, I'm going to try to get rid of x. So you multiply each other's coefficient, but one of them have to negative, so you can have an opposite sign. So when you do that, multiply 3 with the first equation, negative 2 with the second equation. So when you do that and do the column addition, after that you convert them into case 1, x disappears, y disappears, and number even become 0. So you end up with 0 equals 0. Well, 0 is always 0. They are always equal. This is a true statement compared to the other one was a not true statement because 0 never equal to 8. So in this particular case, the final answer would be not 0 equals 0. Your final answer become many solution with a different dependent system, because you have a many solution that makes 0 equals 0. Okay, so that is a type 2 and type 3. So again, the rule for the inconsistent and dependent system is when you have, after you make a equation, system of equations to case 1 style, and when you do the column addition, you have 0 equals some number like 12. Then this is a inconsistent system. But you do the same way, but if you have 0 equals 0 or 5 equals 5, after you solve it, then it becomes dependent system or many answer, many solution question. So again, the type 1, you get x and y value individually. So x equals something and y equals something. Type 2, no xy. And type 3, again, no xy. So type 2 and type 3, you don't have xy, no xy values. And then not only xy all cancel out, if you have 0 equals 0 way, and the 0 equals 0 or 5 equals 5, we call this one as a dependent system with many solutions. And if you end up with a 0 equals some number, we call that one as inconsistent system with no solution that makes that. Okay, so now let's do some practice from your workbook. And you can always pause this video whenever you want, and you can always go back and listen many times on the area that you are weak on it, or any area that you didn't understand. Okay, so this is the end of this particular video. Please do some problems in the workbook, and then let me see you again. Okay, I'll talk to you soon. Thank you.